Hey guys, in this video we are going to explore yet another interesting built-in module in Python called functools. The functools module is for higher order functions. Now, what do I mean by that? Well, actually, higher order functions treat the functions as objects. They can take functions as arguments, manipulate them, and even return them as output. Now, functools is a kind of module which you do not necessarily need, but you can use it to make your code look better and even efficient sometimes. So in this video, we are going to be exploring some of the important functions provided by functools module. So without any delay, let's get started. Okay, so let us start with a function which was not initially a part of the functools module. I'm talking about the reduce function. The reduce function was originally an inbuilt function in Python, but when Python 3 was released, then it was added to the functools module, and the reason will be clear very soon. So we have got from functools import reduce, and now first of all, let's say a very simple scenario where we might need reduce. So let's say we have got a list, we have got 5 elements like this. So a very simple way of finding the sum of this list is that you start with the first 2 elements, let's say 1 and 2, then you find the sum of them, so it becomes 3, and you have your remaining elements still lying there. And now you to your sum of 1 and 2, now you add the next remaining element of your list, which is now 3. So 3 plus 3 becomes 6, and you still have 2 elements more, and then to 6 you add the next element, which is 4, so it becomes 10 and 5 is remaining, and finally you get 15 when you add 10 and 5. So this is a very simple way, and this is called rolling computation, and you're basically just reducing your problem space by taking 2 elements at a time, just adding them up, and then finally you reach a value which is your final answer. That is exactly what reduce does, and that's in the name actually, right? So let us see how reduce works. So reduce takes 2 default arguments. One is any kind of function, and the other argument is any kind of iterable. Iterable means anything which can be iterated upon, for example, list, set, or tuple. So the reason that reduce is a part of functools is now clear, because the first argument that reduce takes is a function, and since I told you before that functools deals with higher order functions, the functions which deal with functions, the function which takes functions as input, manipulate functions, and even return functions as output. So that is what we are dealing with here. So let me provide a simple lambda function here, and reduce will be taking the functions which take 2 arguments as input, because it has to work upon 2 arguments at a time for its rolling computation. So we are going to do lambda x comma y, 2 arguments, and we are going to just return the sum of them. And now time provide my iterable, which is, let's say, 1 2 3 4 5. So if I run this, I get the output as 15, which is correct, right? You can do a few more things with this reduce function. Let's say you want to find the product or overall product of your list, then just replace plus with multiplication, and you get the output, because the logic remains same. Similarly, you can find the maximum value in any given list by just replacing that with max of xy. So basically, in this rolling computation, you will finally get the global maximum eventually. So yeah. So one more thing that you can do to reduce function is that you can provide an optional argument, which is the initiator. So by default, the initiator is the first 2 values that you have in your list, but if you provide an initializer here, for example 10, then what will happen is that you will start with 10 and the first value of your list, in this case, which is 1. So first of all, it will be 10 plus 1 11, then 11 plus 2, and so on. So if I do it here, I think we should get 25, right? So yeah, so we get 25. So in this way reduce works, and I hope that's clear. So let's move on to the next function. So I hope you must be familiar with the magic functions in Python. So the magic functions are basically the functions which you usually define in your class definition, but you do not need to invoke them directly. They are invoked internally when you take some kind of action over your class objects. So for example, you can define the equality magic function, which is whose name should be double underscore eq double underscore. So if you define that function in your class definition, and then you try to use the double equal to operator over the objects of your class, then this function will actually get invoked. So in this way, similarly, you have some other comparison magic functions as well. You have less than, equal to, greater than, and greater than equal to. So here, for example, I have this class called car which has two properties, model and mileage, and for equality it is checking if the mileage is same or not, and for less than, it is checking if mileage is less than the other mileage or not. So if I just try to create two objects, and if I try to see if C1 is equal to C2 or not, I get false, and if I try to do C1 is less than C2, I get true. So as simple as that. But if I try to do C1 is less than equal to C2, then I get a type error which says that less than equal to is not supported, right? And it is actually true because I have not written any function here which is double underscore le double underscore, which is less than equal to. So what I have to do is that I have to just write that function as well. So for that I will be just be doing something like this. I'll be renaming the function. Now I'll be making it double underscore le double underscore, putting this thing in here and then running it, right? So this is one way of adding more comparisons, supporting more comparisons. But there is one more way which functools provides you, which is called total ordering. So total ordering is a function which is used as a decorator, and first of all let me import it. So from functools import total ordering, and now over our class definition we are going to put that decorator. So now what will happen is that total ordering will automatically generate the remaining comparison operator magic functions for me here. So in the docs you can see here, this is the total ordering. So the minimum requirements which are needed for implementing or using total ordering is that your class must define one of the less than equal to, greater than equal to, and also the class should have the equal to method as well. So at least two methods, where one will be always equals to and then the other will be one of these four, that should already be defined, so that according to that reference you can create the other comparison operators. So once that is done, then it can automatically generate the remaining comparisons, right? So I have put at the rate total ordering. So let me just reload my class definition, and now when I create my objects again and I just check the less than equal to, it works. And even though I have not written the code for that by myself, right? So it works in that way. And if I just try to see greater than equal to, that also works. So yeah, so this is what total ordering does. Nothing too fancy, it's quite simple. And something to note here is that this decorator does come at the cost of slower execution. Your code might you might notice that it might be a bottleneck in your application because it slows down your application in some cases. And also when some error happens, then you might get some more complex stack trace because of doing this, right? So keeping those things in mind, you should decide if you want to use this or not. But for simple cases it's quite handy, and I think you should use it when you just don't want to repeat the code again and again. Okay, so before I talk about the next function of the functools module, let us talk a bit about the property decorator in Python. So what property decorator does is that it makes you treat your class methods as actually class properties. So let's take example of this class called marksheet, where you have a grades property which you are setting at the time of the running of your constructor function, right? So you also have two class methods which are total and average. So these two have been decorated with the property decorator. So what happens now is what we're going to see. So if I do m dot total, basically I'm not doing m dot total function, I'm just doing m dot total like a property of my class. Then you are actually running the function, you are getting calculating total and the value, right? So if I just run it again, you are getting the value again and again. The function is actually running, right? You are not referring to a particular object, you are actually calling a real function again and again when you want to get the value of a particular property of your class, right? So similarly, if I do m dot average, I will be getting this, right? So calculating average is printed first, then calculating total is printed, and then I get the value as 95. So it's as simple as that. And now one thing to think about here is that, do you need to calculate or run these functions again and again? Even though you are using the property decorator, but that doesn't mean that you have to calculate the total value again and again or the average again, because that value is going to remain same. So what you can do is that you can remove all this and just keep a property right here in your constructor only with self.total equal to sum of grades and something like that, that is an option. But let's say you want to stick with the property decorator only, then in that case what you can do is that you can use functools cached property decorator. So cached property is actually new in version 3.8. If you're using Python 3.7 or less, then you won't be able to use the cached property decorator. So if you really want to test it, then you better use Python 3.8. So from functools, import cached property, and now just replace the property decorator with cached property decorator. So cached property decorator is just the property decorator plus the caching support. So let us see how it works. So I'm just creating the marksheet object again, and now let me just do m.total. So look at that, first time I'm getting the calculating total printed because the function ran, of course, but from the second time I'm never gonna see that printed again because I'm not actually calling the function again. The function is not running again, and you are just getting the cached value. Same thing goes for average. You will just see calculating average first, and after that never. So in this way we are caching the property value, and we're not running the function again and again. So this is how you can use the cached property decorator from functools. Okay, so for the use case of our next functools function that we are gonna look into, let's see this Fibonacci function. So we have defined a function called fib, which takes n as input and it returns the nth number in the Fibonacci series. So the Fibonacci series goes like 0, 1, 1, 2, 3, 5, 8 and so on. So the property of this series is that it starts with 0 and 1 and the next element is always the sum of the last two elements. So that is the property of the Fibonacci series, and we have written a recursive function for it here where we are trying to find the nth Fibonacci series number. So what I've done here is that I have written a very simple loop kind of thing here where I am trying to print the first 10 Fibonacci series numbers. So let me just run it. So actually I'm also printing like for what value of n I am calculating the Fibonacci series number. So if you look at the output, that seems fine. You have got 0, 1, 1, 2, 3, 5, 8 and so on. But the problem that we have here is that we are calculating the Fibonacci series value for the same value of n a lot of times. For example, for 2 you have a lot of occurrences, like 2 is here, 1, 2, 3, 4, 5 and a lot of places, right? So and same goes for other values as well. So we are recalculating a lot, and that is where we can use the concept of caching. So caching is like in some temporary space you store some recently used values so that you can use them again and again instead of recalculating it. So a very nice module, functools, which we are talking about in this video, that provides you something called LRU cache. So LRU cache is used as a decorator, and all you have to do is you have to put it like this and provide the max size. So max size actually refers to for how many last recent calls do you want to save the information. For example, if you put max size equal to 2, then it will remember the input and the output of the last two calls. And if you make it, let's say 128, which is actually the default value, then it will remember the output of the last 128 calls that were made to that function. So if your input matches with any of those last 128 calls, then it will return you that value without recalculating it again. So that is what max size does. So if max size is equal to 0, then that is of no use, and even if it is 1, that might not be of much good use if you are not so if you put max size equal to 1, let's say what happens, right? So not a lot of change that you can see, which means that you're not calculating fib2 and again fib2 consecutively, so it is not getting used much, right? Let me make the max size 2. Okay, so you can see that the size of the list has decreased quite a lot, right? So now let me make max size 3, which means that you're remembering the last 3 calls information, the input output. So look at that, the list has decreased much. And if you make max size 4, then quite same. Okay, so let us just make it 128 the default value. And okay, actually it will be printing those, right? 2 3 4 5 6 7 8 9 are going to be printed because you have to calculate them at least once anyways. So yeah, so that is not going to change. Okay, so we are fine with it. And one thing that you can also see here is fib.cache info. So fib.cache info will provide you the information about the caching that happened. So it says that there were 16 hits and 10 misses. So hits means that the value was found in the cache only and you didn't need to run the whole function again. So that happened 16 times. There were 10 misses because you didn't have that value already, and that is understandable because for 2 3 4 5 6 7 8 9 and also 1 you had to calculate that value at least once. So that's why you are seeing 10 misses here. And current size is 10, which means that you are holding up the information or the value of the last 10 calls, and the max size as we defined is 128. So yeah, so that's fine. If you make max size none, then it is like a store which has no limit. It will be storing everything. So that is also something that you should know. And other than that, there is another optional parameter which is called typed. So typed, I think, is new in Python 3.8 actually. Yeah, okay, so no, it is not new. We have another thing which is new, but type was actually added in 3.3 only. So what type does is that if you put type equal to false, then it will treat the different types, for example int and float, as two different values. So 3 and 3.0 will be treated differently if you put type equal to true. Actually, if you put typed equal to true, then they will be treated differently, and if it is false, then 3 and 3.0 will be treated as same. So yeah, so that is fine. And the new thing in Python 3.8 is that you can use LRU cache without making it a parameterized decorator. You do not need to put any kind of parameters here. You can just keep it like this, and in this case the value of max size will actually be 128, as we can see here, and it will run just fine. So yeah, so this is how LRU cache works. It is least recently used. It stores the most recently used calls up to the given limit. For example, by default it is 128. So yeah, that's it. Okay, so let's talk about a very simple scenario here. Let's say we have got a function called add, which takes two parameters as input, a and b, and it just returns the sum of them. And now I want to create another function which just returns, which just increments the value of any given number. So for example, you can just make it like add 3 comma 1. So you're just incrementing the value of 3, right? But you want to have a specific function which takes only one argument as input. So in that case, you can do something like add underscore 1. Let's say the argument name is a, then you return. You can just do add a comma 1, something like this, right? So you can do this, and now the user can do add 1, in which let's say they just pass 5, so that they get 6, right? So it's as simple as that. So the same thing that I did here by making a new function and all, I can do that in a single line by using something called partial function defined in the functools module. So I'm just gonna remove this one, and now I'm just gonna import partial function from functools. So from functools import partial. So now I can do add underscore 1 is equal to partial add comma 1. So now if I do add 1, let's say 4, I get 5. As simple as that. So what happened here is that the add function is now by default taking 1 as the value of a. So let us just confirm that first. So print a comma b, and now let me just make the partial again. Yeah, so the value of a is actually 1, and the remaining values now have to be provided by you. So that is what you're doing by providing add 1 with value of 4. So that becomes the value of b. Now let's say you want to provide the value of a as 1. Let's say you want to provide the value of b as 1 by default. So what you can do is you can say b equal to 1. So just provide it like a keyword argument, and here you will have to now, if you now try to run this, you will actually see that now a is getting passed as 4 and b is the, since you defined it as 1, that is getting back as 1. As simple as that. But if you make a is equal to 1 here like this, and now you run it, you are getting an error. It is saying that add got multiple values for argument a. So why is this happening? It's happening because you are providing the value of a as 1, and now you are in a way not providing the value of any positional argument from your partial function. So when you are providing a positional value from here, then it is being set as the value of a also. So in a way, two people are trying to set the value of a at the same time, and that is causing the error. So what you have to do is that you have to make this value, the 4, as another keyword argument. So I can do b equal to 4, and that should work. So in this way, you are basically removing the ambiguity, and hence you are able to make it work properly. So yeah, so this is what partial does. It just lets you create partial functions, and those functions simply work. Okay, now for the next function that we are going to discuss in the functools module, let us see this first. Like, what example do we have here right now? So I have actually created a decorator function which is called mylogger, and what it does is that it basically takes your function as input, and it has a wrapper. It wraps your function with that wrapper function, and it just returns that wrapper. So this is basically a simple decorator that I've created here, and it is doing nothing but it's just printing the name of a function. It is like doing running the name, function name, and then it is actually running the function after that. So it is a very simple logger that we have here, and then I have put it as a decorator over my function called add, and I've also given some doc string to my function add. So it is as simple as that. So now if I try to do add 1,2, I get running add and then the output, which is fine. Now if I try to do add dot double underscore name double underscore, which should return me the function name, look, let's see what do we get. Look at that, we're getting wrapper. Why is it happening? It's happening because when the function was executing, like right here, it was inside the wrapper function. So that's why we are getting the output as wrapper. Similarly, if I try to do add dot double underscore doc double underscore, I get nothing, because even though I have the actual doc in my add function, but wrapper function has no doc. So that's why we are getting nothing. So this is a problem, because I should be able to get the name of the actual function that I want, because the wrapper name doesn't mean much to me when I am actually running the add function, right? So to get rid of this problem, functools provides you something called wraps. So from functools, I'm going to import wraps. So wraps is a decorator which you just put over the function which is wrapping your actual function, and you just pass the function, the original function, to it as a parameter. It's a parameterized decorator. And once you do that, now if you just try to run your code again, then the name will be fine, which is add, and the doc string will also be fine. So this is what wraps does. It basically makes your the original identity of your actual function visible back to you again. So that's what it does. Okay, so consider this piece of code which has been written here. It is called append underscore 1. This is a function, and it takes an object as input, and if the type of object is list, then it just puts 1 at the end of the list. If it's a set, then it takes the union of the existing set object and 1 as a set, and if it's a string, then it just appends string 1 to that particular string which has been put as input. So yeah, and if it is nothing, it is none of those types, then it just prints unsupported type and returns back the object without any change. So it's a very simple function, append 1, and let us try it out a bit. So append 1, let's say we put 1 2 3, then we get 1 2 3 1, and if we do append 1 with a set, then we get append we get 1 2 3 back again, because union will return you the same thing here. And if it is abcde, then you get abcd1. So it's a very nice function which is doing this job for you, right? But now I'm going to introduce you to the concept of single dispatch generic functions. So first of all, what is a generic function? A generic function is a function which is composed of multiple functions which are implementing the same operation for different types. And it is actually quite a lot like what is happening here, but it is another thing that here you are doing everything in the same function. But what I'm calling a generic function is a function which is composed of multiple different already existing functions which are trying to implement the same operation but for different types, the different data types of the inputs. So now which implementation or the which function of those would you want to call, that depends upon the dispatching algorithm that you have, and that can depend upon the type of the input that you are getting. For example, in this case, if the type of object is list, then let's say you want to do this operation. If the type of object is set, then you want to do this operation, and so on, right? And the only difference in what we are doing here and what I'm talking about generic functions is that here everything has been put together in the same function only, but in case of generic function, we call the function by the same name, but actually the function internally is calling or using different functions which are working for different types. Basically, that's what is happening. And single dispatch simply means that in case of single dispatch, you choose which implementation to use on the basis of the type of a particular argument from your input. And in our case, we already have a single argument, so that is going to be object only. So on the basis of object, we will decide which function to actually call. So now let us see what all is happening, what all is going to happen here. So I'm going to introduce you to something called single dispatch function in the functools module. So from functools, import single dispatch. Okay, so now what I'm going to do is that I'm going to define append one again, and it is still gonna take the object obj as input. And right now I'm just gonna write something called pass. So this function is gonna do nothing, but I'm gonna put a single dispatch over it. So now what can I do is that I can create multiple implementations of this function. And how is that possible? You just need to do append underscore one dot register, and now you're registering this particular function to do something. Now you can also tell on basis of what type, in which case would you want to run this particular function that you're going to define here. So let's say I want to do that when the type of my object is a list. So if the type of my object is list in the append one function, then I want to run this function. So let me just call it append one list. Well, actually the name of this function doesn't matter to me, so I can just replace it with underscore only, and the input will be obj. So the input has to remain same for all the implementations here. And now I'll be doing same thing which I was doing for the list in the original function. So just want to copy that here, right? And similarly I will write the implementation for the remaining ones. So list, then we have got a set, and finally we have got a string. So these are the three implementations that I have. And what am I doing in each case? So let me just replace it with the actual implementation, and this will be object plus string one. So yeah, so this is done. So now what we have actually done is that now if I do append one, let's say 1 2 3, will it work or not? So if there is no single dispatch here, then it should not work because you are just doing pass, so that will do nothing. But right now if I run it, look at that, I'm getting 1 2 3 1. So why did it happen? It happened because single dispatch. So first of all, single dispatch made your append one function generic, and then added the property that on the basis of the type of this object argument. So by default it takes only the type, it only considers the type of the first argument of a function. So the type of object is seen and it is matched with these values, and since it is a list, then this function is run. So now let me replace 1 2 3 list with some kind of set, then you get the value for a set, and replace it with something like ABCDE, and you get the output. So it's as simple as that, and this thing actually looks much more cleaner, right? And if I just replace this with, let's say, an integer, let's see what happens. You're getting nothing. So that is actually happening because the fallback, when you are not able to match it with any of these, the fallback is your original function. So here I replace pass with, let's say, print the same thing that I had here, print unsupported type, and return the object back. That is what I'm just gonna paste here like this. So now if I just do append one, it is saying unsupported type and then just return one. So as simple as that. So in this way, single dispatch works. It makes a generic function for you, and then it's upon you how you want to dispatch that particular any function call. Since Python 3.7, there has been the support for type annotations. So instead of doing all this, putting list here, you can simply do object list, and here as well you can simply replace it with type annotations in Python. So these are used for type hinting, and you can just put it like this. So this will also work and looks a bit more cleaner. So 1 2 3, it should work for you. Yeah. So in this way, we can use the single dispatch, and it's quite cool when you have the case or a scenario where on the basis of a particular argument you need to take different kind of actions, and there are multiple cases. So there you should use single dispatch. So yeah, so I think that was all that I had for functools. We discussed a lot of interesting functions, and I hope you enjoyed it. And if you still have doubts, you can put them in the comment section below. That's it from this video. Thanks for watching.